Section 3 focuses on significant figures and calculations. So we are going to be able to give the correct number of significant figures for a calculated answer. In calculations, calculated answers are usually rounded off. You all remember how to round. So we will be using rounding rules to get the correct number of significant figures. If the first digit to be dropped is 4 or less, then it and all of the following digits are simply just dropped from the number. If the first digit to be dropped is 5 or greater, then the last retained digit is increased by 1. Let's look at some examples. Let's say that we do a calculation, and this is what our calculator tells us, 8.4234. But let's say that I can only have 3 significant figures for my answer. I would count 1, 2, 3. So draw a line after 3. Will that 3 do anything to that 2? No. So we simply just drop off the 3 and the 4 and leave it at 8.42. What if I only needed 2 significant figures? So I had 8.4234. So again, I would just count 1, 2, draw a line after 2. Will the 2 do anything to the 4? No. So we drop it and all of the remaining off and just leave it at 8.4. Then we have 14.78. If I wanted 3 sig figs, I would go 1, 2, 3 and draw a line. Will the 8 do anything to that 7? Yes, it will. It will round it up because 8 is larger than 4. So this would become 14.8 to have 3 significant figures. If I only wanted 2 significant figures, 14.780, I would count 1, 2. Will the 7 do anything to the 4? Yes, it will round it up to 15. What about 3,256? If I wanted 3 sig figs, I drew these both right here. 1, 2, 3. I'm going to draw a line after the 5. Will the 6 do anything to the 5? Yes. It will round it up to 3, 2, 6. But I can't just stop there because 3,256 is nowhere near 326. No. Yet, while we do drop this number, we have to put a 0 there. So 3,256 would round to 3,260. This is 3 sig figs because remember the 0 at the end is just a placeholder, giving us 3 significant figures. To have 2 significant figures, I would simply go 1, 2. Will the 5 do anything to the 2? Yep, it'll round the 2 up to a 3. And then these that I drop, I just have to put zeros as placeholders. So 3,256 would round to 3,300. Why don't you try these 3 example problems to round off to 3 significant figures? So pause the video. Let's see how you did. 3, 1, 2, 3. I'm going to draw a line up to the 7. That 8 will round that 7 up. So 35.8 meters. For this next one, these are just placeholders. So I'm going to start counting at 2, 6, 2. That's 3. That 1 will not do anything to that 2. So 0.00262 liters. 1, 2, 3. That 6 will make that 2 round up. So 3.83 times 10 to the 3rd grams. Now there are some rules for when I multiply and divide numbers. Let's say that I do 2.8 times 67.40 and then divide all that by 34.8. Your calculator is going to give you a display with a lot of numbers. When you multiply or divide, you have to count how many significant figures each of your beginning numbers has. So for example, this has 2 significant figures. This guy has 4 sig figs. This one has 3 sig figs. And your final answer can only have as many as the smallest number. So this 2.8 is 2 sig figs, so I have to finish with 2 sig figs. So you take your big old calculator display and you simply go 1, 2, draw a line. Will that 2 do anything to that 4? No. Your final answer would be 5.4. Now be careful when you're using your calculator. What if I had 8.00 divided by 2.00? And you plug that into your calculator is going to tell you 4. So it's easy to just write down your answer of 4. But we have to look at significant figures. 8.00 is 3 sig figs. 2.00 is 3 sig figs. Remember, our answer will have as many as the smallest of the numbers that we start with. Well, 3 and 3 obviously they're the same, so I have to end with 3 significant figures. So to take the number 4 and make it into 3 figures, we need to make it 0.00. 4.00 would be the correct final answer. Let's look at some sample problems. Perform these, see what your calculator tells you, and then write your answer with the correct number of significant figures. So pause the video here. Let's look at it. 56.8 times 0.37. 3 sig figs, 2 sig figs. So my calculator would tell me 21.016. 2 sig figs, 1, 2, I would draw a line. That 0 is not going to do anything, so your final answer should be 21. For part B, I did my 4 sig figs times 0.585, which is 3 sig figs. 3 sig figs, 3 sig figs. So obviously my final answer can only have 3 sig figs. This is what your calculator will tell you after you plug and chug. 1, 2, 3, it would be after that 8. That 4 will not do anything to it, leaving it at 5.88. Again, 25.0 divided by 5.00, 3 sig figs and 3 sig figs. This is what your calculator will tell you, but that's only 1 sig fig. To make it 3, add zeros after the decimal point. What about if we're adding or subtracting? When we're adding or subtracting, our final answer is written so that it has the same number of decimal places as the measurement that has the fewest decimal places. So if I had 2.045 plus 34.1, this is my fewest decimal places. So that means my answer can only be to that many decimal places, so just to the tenths. So even though I'm going to add it all up, and here's what my calculator tells me, but I need to stop at the tenths. So I'm going to draw a line and say, will that 4 do anything to that 1? Nope. Why don't you try these addition and subtraction problems to see where you would round to have the correct number of significant figures. Pause the video. Hopefully you notice that 104 is obviously significant to the ones. 7.8 is to the tenths. 40, remember this 0 is not significant, so 40 is to the tens place. That's our fewest. So when I add all of these up, my calculator will tell me 151.8. But I have to stop at my tens column. So will that 1 do anything to that 5? No. You should have ended with 150. When I subtract these two, obviously they do not have the thousandths place in common, but they do have the hundredths place in common. So I would look and say, will that 7 do anything to that 2? Yes. It will make it 138.43. Hopefully you feel pretty good about this section. Check and make sure that you feel comfortable with these learning goals. The next section, we're going to look at prefixes and equalities. We're going to use the numerical values of prefixes to write a metric equality. In the metric and SI systems, a prefix attached to any unit increases or decreases its size by some factor of 10. The relationship of a prefix to a unit can be expressed by replacing the prefix with its numerical value. So 1 kilometer is equal to 1,000 meters. And I can write that and say 1 kilometer, in 1 kilometer there's 1,000 meters. Or I can say in 1,000 meters it's equal to 1 kilometer. These are equalities. Here are some metric and SI prefixes that increase the size of a unit. A kilo is 1,000 of those base units, whether it's a kilometer, kilogram, kiloliter. That means that's 1,000 meters, 1,000 grams, 1,000 liters. Obviously, you've heard of the Mega Millions jackpot. Well, if I won the Mega Millions, that means I won $1 million. If I had a megameter, I would have 1,000,000 meters. If I had a megagram, it'd be 1,000,000 grams. Same with a giga. You've heard of a gigabyte. Well, that's 1,000,000,000 bytes. And then there's tera and there's peta. And you can see how they get bigger and bigger by factors of 10. Here are prefixes that decrease the size of the unit. Comparatively, we said a megameter was 1,000,000 meters. A centimeter is 100th of a meter. So it would take 100 centimeters to equal 1 meter. Or we could say 1 centimeter is 100th of a meter. A millimeter would be 1,000th of a meter. 1 millisecond is 1,000th of a second. Or I can say 1 second is 1,000 milliseconds. The relationship of a prefix to a unit can be expressed by replacing the prefix with its numerical value. For example, when the prefix kilo in kilometer is replaced with its value of 1,000, we can say 1 kilometer is equal to 1,000 meters. 1 kiloliter is 1,000 liters. 1 kilogram is 1,000 grams. Let's look at length equalities. Any equality shows the relationship between two units that measure the same quantity. For example, 1 meter is equal to 100 centimeters, or 1 meter is 1,000 millimeters. So we can say 1 meter equals 100 centimeters. 1 meter equals 1,000 millimeters. We can therefore say that 100 centimeters equals 1,000 millimeters. Notice that there's only a tens difference there. So 1 centimeter actually equals 10 millimeters. The metric length of 1 meter is the same as 10 decimeters. So if this is 1 meter, 10 decimeters, 100 centimeters, 1,000 millimeters. Notice that the difference is just increasing by a power of 10. A volume of 1 liter or smaller is commonly used in the lab. When a liter is divided into 10 equal parts, it's called a deciliter. So again, we've got some values here. We can say 1 liter equals 10 deciliters. We know 1 liter, there's 1,000 milliliters. So then I can also just say, well, if 10 deciliters then equals 1,000 milliliters, we know that these are equal because these are both 1 liter. Well, to make 1 deciliter, we would divide both sides by 10. So that would give me 1 deciliter equals, and we would cancel out one of these zeros, 100 milliliters. That's how they got that number. Another way to measure volume is by the cubic centimeter, or cm3, cubic centimeter, or sometimes it's written as cc's. It's the volume of the cube with the dimension 1 centimeter by 1 centimeter by 1 centimeter. So this is a centimeter, so length times width times height is how we would get cubic centimeters. Or 1 cubic centimeter is equal to 1 milliliter. So a centimeter cubed is equal to a milliliter. This is the same volume. And in this cube shape, 10 centimeters by 10 centimeters by 10 centimeters, 10 times 10 times 10 would give me 1,000 cubic centimeters. And 1,000 cubic centimeters is equal to 1 liter. When I'm measuring mass, for example, your body, the mass is measured in kilograms. If I'm measuring something smaller in mass, I would measure it in grams, or milligrams, or micrograms. We can have some equalities for mass, like saying that 1 kilogram is equal to 1,000 grams. 1 gram is 1,000 milligrams. I can then set and say that 1 milligram is 0.001 grams. 1 milligram is 1,000th of a gram. These two are just oppositely written. Hopefully this section made sense. Go through these learning goals and make sure that you feel comfortable with them. I gave you a taste of section 5 a little bit earlier when it comes to writing conversion factors for 2 units that describe the same quantity. This can be between units of the metric system, between US units, or between metric and US. All that means is when we know a quantity, 1 meter is equal to 1,000 millimeters, we can also write that as that there's 1,000 millimeters per 1 meter. Or we can say that for every 1 pound, there's 16 ounces. Or we can say that there's 16 ounces per pound. Same with this. This is between metric and English. There's 2.205 pounds in 1 kilogram, or in 1 kilogram, there's 2.205 pounds. These are conversion factors, writing those equalities, either or, with the 1 meter on top or the 1 meter on the bottom. Remember that when we stay within the metric system or stay within the US system, that these are by definition, they are not used to determine significant figures. Equalities written between metric and US quantities contain one number obtained by measurement and therefore count towards significant figures. 1 pound is equal to 453.6 grams. Apparently, an exception though to this, because this is in English and this is a metric, this is defined as exact. So this would not count towards sig figs. Here's another example of a conversion factor. If 60 minutes is equal to 1 hour, we can say that there's 60 minutes in 1 hour, 60 minutes per hour, or we can say in 1 hour there is 60 minutes. So we can write it either or. Why do we care about these conversion factors and equalities? Well, because we're going to be able to solve problems using these conversion factors to change from one unit to another. The problem-solving process begins by analyzing the problem in order to 1. Identify the given unit and the needed unit. Write a plan that converts what we're given to what we need. Identify one or more conversion factors that will cancel units and give us the unit that we need, and then calculate. In radiological imaging, such as a PET or CT scans, dosages of pharmaceuticals are based on body mass. If Greg weighs 164 pounds, what is his body mass in kilograms? Now you would always be given the information that you would need to get there. For example, you would be told that 1 kilogram is equal to 2.205 pounds. Let's write the conversion factors that this would allow us to do. I could say 1 kilogram is equal to 2.205 pounds, or 2.205 pounds in 1 kilogram. Now how do we go from 164 pounds to we want kilograms? So what do we want? Here's what the trick is. What we want over what we've got. What do I want? I want kilograms. What have I got? What unit do I've got? I've got pounds. I need pounds and pounds to be diagonal from each other in order to cancel out. So I need the conversion factor with pounds on the bottom, which would be this guy. 1 kilogram is 2.205 pounds. Again, notice pounds and pounds cancel, leaving me with the only unit would be kilograms. There's our conversion factor, and if you plug this into your calculator, 164 times 1 divided by 2.205 should give me, with 3 significant figures, 74.4 kilograms. Sometimes we need to use more than one conversion factor. Sometimes 2 or more conversion factors are required. Let's say that your new car has a fuel consumption of 39.0 miles per gallon. We want to convert this into kilometers per liter. Again, we would need to know some conversion factors to get started. Here's what we're given. 1 kilometer is equal to 0.6214 miles. And we also know that 1 gallon is equal to almost 4 liters, 3.785 liters. Let's start our problem with what we're given. 39.0 miles per gallon. So I can drive 39 miles on 1 gallon of gas. Let's set up our first. It doesn't matter if we get rid of miles first or get rid of gallons first. It doesn't matter to me. Let's just get rid of miles since it's on the top. So that means for my conversion factor, I need miles on the bottom. So let's take this conversion factor and we're going to put this miles on the bottom. The 0.6214 miles is equal to 1 kilometer. So miles and miles will cancel. If I were to stop right here, the unit on top is kilometers. So this would be kilometers per gallon, not kilometers per liter. So we need to go one more. To do that, so I got to get rid of gallons. That means if gallon is on the bottom, I need gallons on top in order to cancel out. So let's put my 1 gallon on top and my 3.785 liters on the bottom. Gallons and gallons will cancel, leaving the only unit on top is kilometers. The only unit on the bottom is liters. So 39 times 1 will give me 39. And then I need to do 1 times 0.6214 times 3.785, finishing with 3 significant figures, since that's what I started with, to get 16.6 kilometers per liter. And again, make sure that you plug and chug and that you rounded correctly. Check over the learning goal to make sure that you feel comfortable. Here's a chart with a lot of conversion factors. When we're measuring the length of something, we can say that 1 kilometer is equal to 1,000 meters. We can say 1 centimeter is equal to 10 millimeters. 1 foot is equal to 12 inches. Anytime that we have any of these equalities, we can write them as either 1 kilometer over 1,000 meters, or we can say that there's 1,000 meters in 1 kilometer. All of these equalities can be written as reciprocals of one another. Here are a bunch of equalities measuring volume, measuring mass, and measuring time. We can say that in 1 hour there are 60 minutes, or we can say 60 minutes is equal to 1 hour. Conversion factors can be written for any metric relationship. Both conversion factors represent the same quantity. One is just the inverse of the other, or like I said, it's the reciprocals of one another. If I'm told that 1 meter is equal to 100 centimeters, I can write it as 100 centimeters over 1 meter, or 1 meter over 100 centimeters. And it doesn't have to just be the metric system. We can have conversion factors between the US system or the English system and metric system. For example, if we were told that 1 kilogram is equal to 2.205 pounds, we could say that there are 2.205 pounds in 1 kilogram. We can also say that 1 kilogram is equal to 2.205 pounds. How do we know which one to use? Well, it all depends on whatever unit you're starting with. If I said a baby was born and it was 7.2 pounds, and I wanted to know what that was in kilograms, I would set it up and say, well, what do I want? I want kilograms. What have I got? I've got pounds. So I want the conversion factor where the kilogram is on top and pounds is on bottom, which would be this. I would say 1 kilogram is 2.205 pounds. There are also equalities on food labels that you may have noticed, listed in both metric and US units, and it indicates the same amount of a substance, but just in 2 different units. You've probably noticed, let's say this cereal box, Cheerios, it says net weight is 15 ounces or 425 grams. Those are equal to one another. Or the 5 ounces is equal to 142 grams. Lots of packaging in the United States have food listed in both English and metric units.